Alrighty, on to 5.6. Hopefully you guys are doing this in your math notebook. That way you can look back and review what you did yesterday. If you're not doing it in your math notebook, please do it now. We're going to use area model again to show equivalencies, just like we did before. And this time, I'm going to ask you to just start doing your drawing. Would you please draw a whole area model and shade in 3/4? Draw a whole area model and shade in 3/4. Pause while you do it. Here's what you should have made. This is a whole, but I've only shaded in 3/4. 1, 2, 3 shades out of 1, 2, 3, 4 pieces. I want you to think about how you can turn 3/4 into eighths. How could you actually turn it into eighths? What would you do? If you need to talk to somebody about it, go ahead. If you don't need to talk to somebody and you know what to do, go ahead and cut this so that I now have 8 pieces, not just 4. Pause while you do that. Hopefully yours looks like mine. I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. But now the question is, how many of those 8 pieces are shaded in? Well, if you said 6, you're right. 1, 2, 3, 4, 5, and 6. I want you to go ahead and write me an addition sentence and a multiplication sentence to represent how 3/4 made it to 6/8. So 3/4 equals what plus what plus what plus what to get to 6/8. So let's do a +1 first, and then check back when your plus is done. If you want to do the multiplication one too, you can, but do the +1 definitely first. Pause. And that, my friends, is what it looks like. I have how many 1/8? 1, 2, 3, 4, 5, 6. Because this is 6/8. Therefore, you added them all up, and you got 6/8. Now, if I were to do my multiplication one, this one's going to be a lot faster. If I have 3/4 and I want to get to 6/8, how would I write that as a multiplication sentence? Remember, you can use parentheses. All right, good luck. Pause. And here's what you should have gotten. 6, because I have 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6 times 1/8. Nicely done. So this multiplication sentence, is it the same as this one? Yes, they mean the same thing. You just use multiplication versus addition. So what do they tell us? They tell us that 3/4 is definitely equal to 6/8. We just proved it. Nice job. All right, this time I want you to draw an area model to prove that 2/3 equals 8/12. Draw an area model to prove that. I'm going to be asking for addition and multiplication sentences again, so if you want to do it all, go for it. But draw an area model to prove this. Pause. If your area model looks like this, then you have 2/3 that were originally shaded, and then you cut them so that I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And how many are shaded in? 1, 2, 3, 4, 5, 6, 7, 8. Now again, we're looking for an addition number sentence and a multiplication number sentence. So our addition number sentence, we're going from 2/3 all the way to 8/12. See if you can write out an addition number sentence. How did I get there? Remembering what we did up above. Pause. If you got this, you are correct. We have 1, 2, 3, 4, 5, 6, 7, 8/12. It's like saying 1/12 plus 1/12 plus 1/12, and I'm not going to keep going because that's boring. But I do it 8 times. Now turn that into a multiplication sentence. 2/3 equals, to get to 8/12. How did I get there? Good luck. Pause. And here you go. Now there are multiple ways we could have done this. We could have done it any ways, multiple of ways. We could have broken this into 4 and 4 and done 4 times 1/12 plus 4 times 1/12. Any way works, as long as you end up showing that these two are truly equivalent. And that's what this does. It proves it. All right, the last thing we're going to do is we're going to be modeling some more equivalent fractions. So I want you to draw an area model again, one whole area model. That's not complicated, so let's just do it. One whole area model. Okay. Now, choose any fraction that you want. I would stick small, but you do whatever you want. Okay, go ahead and shade your fraction. And then hand it to somebody in the room. And they need to make it equivalent to something else. So let's say Mrs. Barnes decides to go with, I'm going to do fourths. And let's say I only want to do 1/4. I'm going to take my paper, I'm going to hand it to somebody else. And they're going to draw between 1 and 3 horizontal lines, no more than 3 because it gets too crazy, to show what 1/4 is equivalent to. All right. Let's see. Imagine I passed it to somebody and they came back with this. And they put underneath it 2/8. And I would have to decide if they were right or not. I could take my time and write it out. Equals 1/8 plus 1/8 equals 2/8, just to prove it, if I wanted to. Or by looking at it, I can see that they are correct. All right, the last thing we're going to do is, how in heaven's name do we model 5/3? So here's how we would model 5/3. I want everyone to draw an area model. Oops. And this time, what I'd like you to do is I'd like you to represent just part of it as a whole. Okay, and cut just that part into thirds, because we're doing 5/3, right? I guess I need to fix this middle one, huh? Move that guy over just a little bit. So those are thirds, right? 1/3, 2/3, 3/3. So then, of course, I would just cut this last piece. I guess I'm going to have to make this a little bigger to represent thirds as well. But how many more thirds do I need? I have 1/3, 2/3, 3/3, 4/3, 5/3. So if I do that, I'm going to shade in all 5/3. And I know it's 5/3 because my whole is just thirds. So once I shade all of that in, I want to figure out what 5/3 might be equivalent to. 5/3 equals what? Well, if we go ahead and draw a horizontal line down the middle, or a horizontal dotted line down the middle, what have I now made? Well, let's see. Go ahead and count your spaces. Pause while you do that. If you came up with that I have 10 pieces, you're correct. Now the bottom fraction is my issue. Remember, we're looking at a whole, not all of them. We're looking at just our whole. How many pieces are in this whole? 1, 2, 3, 4, 5, 6. So I would say 10/6. Because I'm looking at the whole. Now I'm going to show you one more little thing. If I had done this to make a whole other whole, this is another whole right here, this still represents 5/3 or 10/6. Because now I have 2 complete wholes. All right, find someone to do the problem set with, and then you can work on homework. Good luck.